Alright, this one's a little bit of a weird one. This is z-scores. How many standard deviations above or below the mean is your value? Is a z-score. So, we use this to compare positions. So this video will be z-scores and comparing position with z-scores. We'll do another comparing position video where we include percents and quartiles and all that fun stuff. But we haven't learned to do that yet. So this is just z-scores and their use. So there's a little formula to find a z-score just because I like the good stuff at the beginning. Your z-score is your value minus the mean over the standard deviation. It's supposed to be a beautiful standard deviation sign. I know it's kind of terrible, but so what I'm going to do is, and I'll draw a picture to help with these too. So you take the SAT and the ACT, and you want to know which score to submit to college. You want to make yourself look as good as possible. Your SAT score was 1250, and the SAT's average and standard deviation are here. The ACT, you got a 27. I know they use such a different scoring system. The average and standard deviation is here. So what you can do is you can see, okay, how many, you can't just say, oh, my SAT score is better because it's 1,200 points better. That doesn't even make sense. They're not even on the same scale. But what you can do is you can see how many standard deviations higher it is. So the easy way is you just say, okay, Z is 1250, again, that's your score, minus 1,000, that's the average, all over the standard deviation, which is 90. If you do that, you get 2.7. I'll show this pictorially in a second. For the ACT one, we'll do the same thing. Z is your score, 27, minus 20.8, all over 5.8. I'm going to have to use my phone to find the z-score for that one because you can't just do it in my head. So we got 27 minus 20.8 over 5.8. Oops, I forgot to use parentheses. Yeah, it's 1.06. Fun fact, when you type this in your calculator, if you don't put parentheses, it will screw you up. That should also say 1,000, not 100. Okay. So, that's the z-scores. So what this is saying is your 1250 is 2.7 standard deviations higher than the mean, whereas the 20.8 is only 1.06 standard deviations higher than the mean. Both are good scores, they're both above average, but by far your better result was on the SAT. You did so much better than the average person compared to just kind of better than the average person. I mean, I'm talking here you're in like the top, you're like in the top 1%, and here you're in like the top 20, 30%. So we'll do that one in another video. Yeah, it's a big difference. If you want to see this as a picture, you can stop now if you feel like you get it. But if you want to see this as a picture, I will show it. I'm going to erase the formulas. Just because it's cluttered, right? You don't need to see my Discord. All right. So if the average is about, I'll just use 21. The mean is 21. That's a z-score of 0. That's right on the mean. No standard deviations higher or lower. The standard deviation is about 6. So z-score, z equals 0, z equals 1. But 27 is almost exactly 1 higher. I used 5.8 instead of 6. I used 6 instead of 5.8. So it makes sense that, like, yeah, if you're like on a number line of scores, and this is average right here, you did pretty good. You were 1 standard deviation higher than the mean. But compared to the SAT, like, your main score is 1,000, 1K. I'll say 1,000. And then you got, you know, this is 1090. This is 1180. You're still higher than that, 1250. The 3 up is 1270. So you're not quite there. So you're sitting like here. with your 1250. That's z equals 0, z equals 1, z equals 2, z equals 3. So like you're like almost 3 whole standard deviations higher than average. That's just more impressive than this one. So if you're ever trying to compare two different things with a different scale, you can kind of think of it like this. But the best way is to just swap to a z-score with your happy little formula and just compare z-scores. It's my favorite way. All right, have a good one, everybody.